So as you can see, this is the property of the soil. You can see black open soil. We are having clay is 70%. So you can see that in soil having 70% clay is here. On its silt is 21%. So this is like CS soil. CBR is very 1 point. You can say 7 days. We can say to 1.9. So almost 2 CBR we are having. But for road construction we require 8 to 10% CBR. So this is your value is only 2% CBR. For road construction required 10 CBR. So this is soil, so we need improvement. So how we can do the improvement? By the mechanical mixing of this aggregate, recycled aggregate or recycled sand, or with chemical, which putting the lime on crystallization by mechanical or crystallization chemical. So this is the physical body of, you can see the construction evolution of waste, that what we get here, aggregate of 40 mm size, 20 mm size, 16 mm size, 4.7 mm size. Impact value also you can see we are getting 39. So sub base 50%, 40%, subsurface is less than 30%. So this is, we can see that sub base and base course we can use at present guideline this same waste. So other parameters are given. Water resistance is very high because of your brick is there. And other materials, cement, we have in case of lime also we have used this GGBF. That is the one of the waste material from steel factory. Okay, so this is also waste of the steel factory. So this here you can see alumina is there, 42% calcium oxide. So this is polyuranic material. So this is polyuranic material we use for stabilization. So this is what we can say the recycled sand and properties. You can see that we got the properties of this sand. We can say 98%. We can see your recycled sand. 98% is your is the sand is there. And this different, when you can see CBR is certainly very high. Will be get. So you can see that phase ventilation is good, just like this non-plastic material that is required for the road construction. So this is the property that we get. So that is mostly non-plastic, means there is no black open soil they are having. This is your recycled sand is having. So this is almost as good as sand. And what is 2%? 2% is only your something silt and clay, that soil that we get during the bringing that materials from the different location to the that side. So recycling aggregate, I can see that different aggregate property is also good, not so bad, so that you can use for a different layer. So that pH value also you can get, you can see is good. Specific gravity of the materials is also is good. So firstly, there are the materials we use. So two materials we use: recycled sand and recycled aggregate. For the subgrade crystallization, means we are using crystallization means not mechanical. Crystallization means only just mixing two metals without any chemicals. We are using lime also. So this is a result. We can. This is a lime with a different curing period. You can see 0 days CBR value of this 100% soil. You can see that and different. So 0 day, 7 days, 14 days, 28 days, 60 days. And you can see that 6% lime with your 50% sand and 50% soil and 50% this you can say recycled sand. The strength is almost 30 CBR we are getting. Means strength from where 2% to 30%. So in any case, even though some you can say we require maximum 10% for the CBR, minimum requirement of the road construction of the subgrade. But all the cases we can see even your so 4% we can say optimized, 4% we can get, or 6% we can get our requirement for the subgrade road constructions for any national highway. Okay, so we can see that we are getting for different combinations that we are getting your 6%, even 4% also, 8% CBR also will do. So this is combination of their different combinations. We are having 8 CBR we are achieving from 2 CBR to 8 CBR. That is one basic first requirement for the road construction. So that we are using CND West, and you can see that using the your recycled sand we are getting CBR is 8% to 10% for different combination. This is other properties UCS means how is this unconfined compressive strength also we are getting, as you can see, improved 7 days. So this is different measurements of the, like when you do the Q test for the concrete, we do Q test, then flexural strength test, different tests. You see, after the CBR test, that is shear strength we get. CBR test means we get shear strength. QCS we get other strength. So flexural strength. So you can see here that we also getting your more than 4 pm very small. We get around you can say 2000 above kilopascals. Durable means we are how because structures if you are constructing it will be durable. Not only after it is not undurable. So durability also you can see combination target you can see that is achieved by 6% of lime. When you apply this your 10% of recycled sand and 60% of soil. Because of soil you can see that almost here in 4% of soil lime crystallization that is achieving durability. So you're because like putting the water, then again coming back, removing again putting the water. So durability also we get this good. So the third quality after the CBR, then ACS durability also it is passing. So your sand. Then this is a three basic. This is the best first layer of the road construction. Next we are going for sub base and base layer. So these are different combinations of we are having. Different recycle aggregate. You can see different cements are there, and your cement content is 3%, 4%, 5%, 6%. Then 20% RCA, 80% natural aggregate. NA means natural aggregate. We are putting combination. 60% recycle aggregate and 40-60%. So you can see that we will see these are combinations we have used 3%, 4%, 5%, 6%, different combinations of this natural aggregate. So your because in India we are taking 20%, but we will use up to 40%. You can see that how much we are getting strength here. This is different same combinations. 100% RC also with natural with this recycled aggregate. Also we have checked with this. So we can see that strength different blends MDD. We can see that here also that in the 100% natural aggregate certainly we get good results, but here also we can see that we are not even 100%, even 60% RCA. We are different MDD we are getting 2.1 we are getting here minimum 100%, because we are not going to say we want 20% RCA and 80% you can say natural aggregate as code is gives direction. So almost both are same. Even so 20% you are adding the recycled aggregate, you are not getting any different as much as you can see in any level. Almost same, little bit here and there, but 20% that also because aggregate you have seen the photograph, some brick particles are there, brick matters are there. Brick is taking water, lot of water is there. If you remove the brick, then it will be as good as natural aggregate. Because then cost will increase for the material. Then again nobody will use. So that brick is there, so that we get some result. So we having any other technology to how to remove the brick from your aggregate, then it will be as good as natural aggregate. That is an important point. So we need one technology intervention to remove brick aggregate from the natural recycled aggregate. So as you can see here that in the program also that is an important aspects. This one you can see your brick aggregate is bricks are very much there. So if having any technology how to remove the brick from there, then this will be as good as natural aggregate. value will increase. So how to cost optimize, because we need cost also there. As present, we don't have any technology to remove this brick. So that's why we are getting, if brick we have removed from this, then it is as good as natural aggregate. Because aggregate is come from rock, having its CTR is 100%. We don't lose because we are underusing this aggregate or rock in our construction activities, road construction basically. Because we need CBR for the road, subgrade is 10 CBR. Next layer is subbase, we need 30 CBR. The next layer, base layer we call 90 CBR, and top layer is called 120 CBR. Just 3 times we increase more. Understand? So, but we got 100 CBR, but aggregate is having 100 CBR, but we are using for 10 CBR. So we are using under the capacity of the aggregate, we are misusing, that we are not utilizing 100%. Only should use aggregate in the top layer, where we need 120 CBR, but we are using for only 10 CBR, 30 CBR. So we are wasting our natural aggregate in this type of underutilizing the strength. That's what where we can do the intervention. That's why this should be improved such a way that we can maximum, because natural aggregate is not man-made, this is natural. So certainly we need intervention so that we can preserve this aggregate and utilize its maximum value. Recycling sand is very important aspect. So 100% recycled aggregate, if you do the cementization, so that you can use in the local food park, we can use this in the different home, we can even mix with the mechanical mixing, we can do some chemical also required, lime we can use, but different, because road construction we cannot do, but other construction we can do, food park, where only just people walking in a park, we can use this. OMC. So optimum moisture content, we can see 100%. We are having, we can see certainly we get maximum water content. So again, there are different technology we should use. Some chemicals are there, like company called Zydex in Gujarat, that they give the chemical for the your water absorptions become 0. They put the chemicals such a way that for the water of the soil to become 0, we can become impervious. So that chemical, but problem is that cost will increase. How much cost will be increased for the coating all over the, then your strength will be also decreased, because anyway your RCA is, if your brick is there, so brick will make it chemical water free, but your strength is not be 100% improved, because you are having a lot of watts, because 10 to 9 to 10% we saw the water absorption capability is there. So we need only 2%, 1%. Water capability absorption is need only 1%, but you are having we got here 10%, because of that, only because of only brick. So even though chemical, so at least we can up to where the strength is not required so much, we can use different places of this with bricks. So 8% to 10% that we can see that it will increase. Then UCS, as you can see that your how much increase, also you can see natural is 100%, is not so bad, almost you can see with the 3%, 6% we can see, but cost will increase. They are putting cement, 6% cement, so certainly your cost will be increased, but strength wise is not so much, where we don't require more than 5 MPa, then you can use that places. Again, footpath and your walking path, cycle track, different places in the village roads where we don't require heavy trucks will going to come. So then we can use that also. Even if 6%, cement is not bad. Although cost will increase, but you can using recycled material, 100% recycled material. So this is also important results. For different blends, durability also, weight loss, because materials weight loss also we can see here is not so much weight loss we get. Target is, I can see the target even so 3% cement we are having maximum 15% weight loss. So all are coming under par. So even the metals can be used for different constructions. Okay. Again, your durability also you can see almost 3%. You can even go for your only 3% is cement, commercial is less. So even 4% cement, we can use this RC 100%, that is sufficient for your target, your durability achievement. Also, it is achieving the durability test. So certainly, this recycling aggregate can be used for different. This is not in the main road like highway. Certainly in the village road, you can use this. So beam load test models of ruptures, you can see that you can see that minimum for the we are getting through here 1.5. This is for the village roads. So those this is only for this. We have made the village road. For highway we need 4.5. The concrete. So concrete 4.5, but here for village road is this is for sub base and base we require 1.5 around the target, that also we are getting. So NP also you can see the strength. Nowadays CBR we don't use CBR because CBR is the static measurement of the strength of the road. So now you are using modulus of resilience or E value. So modulus of resilience means how much resilience that your metal is having. So that is your E value is again stress by strain, as all of you know, that is called modulus of elasticity, stress by strain. But here modulus of resilience means your stress by recoverable strain. How much it is recovered from plastic nature. So that is called your modulus of resilience. So you can see here we can get from 4%, 6% also. We are having sufficient 3000 MPa is more than sufficient value for this what so much required. We require only 700, 750 MPa, but we are having all for the combination more than 3000, 2000. So even so, this is new types of, suppose road base and base is improved more, we are having more strength. So top thickness will be decreased. So geotextile and geogrid nowadays a lot of people are using. So minimizing the top layer of bitumen. Bitumen is very costly. So bitumen thickness is suppose 200 mm. So if we improve this up to 2000, then thickness will become half. So 100 mm required only thickness of the bituminous layer. So national highway all they are using, so they removing only decreasing their bituminous layer 100 mm. So we can see that some this is that Madam Neetu Madam has done research on this topic. So you can see how it looks like scanning your front microscope, how this matters looks like. You can see image of soil 28 days, 90 days. How you can see first of all see the first material your soil. In some soil image you can see very different broken like no it's different you can see different aspects. So that's why black bottom soil we get like that. And when 20 days you can see your soil 40% your recycled soil sand is there, lime is there. You can see gel is forming here. You can see this how fertilization chemical fertilization takes place. This is microscope. Then 90 days you can see almost micro. You can see this whole gel formation happen. So that's what we get strength is increased. In the first we can see here all the soils are broken, different particles. Soil particles you can get, particulates we can say soil particles. Then it become compacted. Here is also compacted more. This way you can see this your soil you can get the figure. Again you can see like is looking like a rock or like speaking rock, not like separate particles. So like rock formation, hills will go, we see the hills like that. So you can see this all are compact. You don't find any so much broken area. This is different. It looks. This is I think this is different materials, no? Different different construction materials like some silica is there, so that the brightness is there. But this is all you can see here, all is looking like a rock. So strength is increased. That's why 3000 MPa. For the soil, we get for the two, we can say 2 CBR, we get a strength is around 20 or 20, we can say MPa, 20-30 MPa. But here 3000 to 1000 MPa. So the nature of the soil will be like that, is a rock. As you can see, all the formation like a granite, you use like granite. That what we use in the, so you can see all are mixed. So this is different type, like in the electron microscope, you can see that how it is in different materials we can check using this graph. Calcium with their quartz is there, montmorillonite is a part of the soil, one of the minerals of the soil. Calcium sulfate is there, calcium carbonate is there, calcium oxide is there. Different materials we can find and we can analyze, and we can based on this we can minimize and maximize different chemicals. So I can see here silicon oxide is there, alumina is there, manganese oxide is there, iron is there. The different particles are there. You can see that. So these are different materials that we find, different elements we find in our this study this CNT waste with different layers of the road. Polyonic reaction synthesize the enrichment. This way, ultimately we are getting polyonic reaction is happening. That's what we want to show you here. And also you can see somebody may ask that maybe toxic nature is there. So you can see here that toxic nature will be found the copper, zinc, lead not detected. Different aspects are mentioned here. You can see that is very low level. That is not detectable, not required, is not harmful for the human being. So this much is there. So finally, based on this data, we have designed flexible payment road. Payment design is offered soil plus 40% recycled sand and 6% lime. And CMD base you can see you are getting 600 MPa. Our second range is 2000 to 4000 MPa. CTB 5000 MPa long term strength for the vehicle the road. A design for 20 year 20 MSA. MSA means median standard axle load, means 20 million standard axle load means 12 ton. We are going to use that road. So that was designed we have done for 20 years. So the input data we have given for thickness we have taken because we have improved the subgrade and subbase layer, means below layer. So bituminous thickness we have kept 100 mm. Okay, DBM and BC extent 3000. We can see granular we have taken E value is 450. If we not take anything generally take, then generally you take 275 or 300. For CTB layer we taking 5000, that is so much because we are taking, and because if you not take general conventional road you take, then you generally 750 MPa. Okay. So this is an input. You can see that how much stress allowed micron strain. So strain one of the measurement of the road, you can say failure criteria. Failure criteria is for the strain. How much strain they have developed. Allowable strain is 225 micron, but we are getting here 131 only. So it is okay, means it is pass. So tensile strain, horizontal strain, vertical compressive strain also allowable is 454 micron, but we are getting 261 because strain is increased. So your strain is become less. Allowable is 450 micron, but we are getting only 261. So we can say that this is your pass. So that is road is good. We can go ahead for the road constructions. So this is just cost saving based on the general economic. Okay, this is economic. So almost 20 to 30% cost is saved because of your RCA and RS. So soil results subgrade layer with reclaimed sand and lime. Optimum blend MR value we got 220 MPa. Required is 60 MPa, but we are getting 200. So what is the important that the strength will be increased, so road damage will be less, maintenance cost will be less, strength will be more, then your maintenance cost will deterioration of road will be less. Range is also increased 8.86 MPa to 8.95 MPa. That also you can see that your TCLP analysis means your any materials are there, that also we got to the limits posing no environmental risk and there is no risk at present. Cost saving 30%, 18 to 30% we got because of RCA and if you with respect to MA. So RCA subscription lower material acquisition cost, that is just we have done this. So this is the road your subgrade where construction is going on. So this is just putting the subgrade on the road constructions, means your lower level. So this CND West you can see your bricks are there, your natural aggregates are there. This is you can see this is soil is removed and we are sterilizing the subgrade, first layer of the road. This is simultaneous base and sub base. You can see that road constructions, but here lime is putting the lime and it is polarizing. Polarizing, mixing the sand with different CND West is here because different materials we are not able to see clearly, but some if it pictures open, but it is some you can see that different materials are there. So this is means already we have done here that Madam Neetu that worked in this her PhD area, and she had concluded that this CND West can be used for the road constructions. That's what we are concluding. So that's what here we can use. You can see it's a small scale here, but this is practical demonstration we have done that it can be used for the road constructions. And this is for village roads. If you go to the village road, this is the specifications we have given that this is a 50 mm crust CND West, 150 mm cement slice CND West, the next layer WBM, grade series, WMM, then DBM and BC that we have put here. This is for village road. So this you can see that whole village road can be made with the CND West. This is the final conclusion of this presentation. Whole road started from here, so we have started road network, and after the road network we have come to the this is the your cross sections or where you can use different CND West. So this is a final we can say recommend for our road, village road constructions and any other even though campus constructions, all these roads can be constructed with the CND West. This is the cross sections for that. So this is the whole presentation. Okay, this is a because after for achieving this we need a lot of 3 to 5 years to achieve all these conclusions. So that madam worked very hard for the other achieving this. So this is the whole video. Thank you. So any questions?
Sir,
Can we use that CNG state highway or national highway?
So like no, that we have seen that states were getting with 6% cement. That we, so that cost will be increased. So that conductor will not going to use high cost, so the cost will be increased. So some incentive required. If you not giving incentive, then cost they not they are getting because you have to get from city from the so cost will increase. Only cost is a matter. State wise we can use. But economic point of view, cost is high, so may not use. But in the local area you can use. City, certainly city can plan, municipality can plan. Yes.
what is the end product of CND waste and who are the buyers actually, and what is the size of market of this CND waste and how?
Like we have discussed now the first part of this, buyers means we are buyers are those who are road contractors. Government should impose, like that you have seen, like in service road when you go to bridge area, underpass, VUP, underpass. When service road is there, it is mandatory to use plastic waste. So government has given you have to use plastic waste in the service road. Same way, government has to give the policy that in the city road you must use 20%, 40% this sandy waste. Understand?
It
Because
is like a fly-ash pella nahi hota.
yes.
Just before some years back, government made compulsory that where the fly ash plant is there na, into 1,000 kilometer range or 100 kilometer range, we have to utilize it compulsorily up to 30%. Similar kind of laws if imposed in the CND waste area also, then only we will get a good market for this. Right now, the fact is that
Yes.
right now market is not available so far. There is only
Demand is not created. This government has to create.
How
Yeah.
many numbers of plants are available in India of this CND waste?
And like tomorrow we'll go that plant you will see.
This is the first one, and
No,
in
no, always
Gujarat
20.
we have two
We have discussed
plants.
now in the first part of the slide. I think 12 or 20 are there. 12. 12 plants are there in India. We are discussing the same.
First plant established in Delhi and later
Yes.
on it is in
Total in
Hyderabad.
Bangalore is there,
and
Hyderabad is there.
Yeah.
Total 12 plants are there. But they are all not very viable. Financially viable. So tomorrow that's why when tomorrow we go there, then we get some idea how to ask the questions, how to understand how market business work. So when you do some innovations, some types of your any innovation do, how market works. Although matters are there, demonstration invest is there, but they are not able to sell. They are not able to utilize. Why? Because of some policy problems and what are the financial problems. So financial or policy problems. So those who are students, they can utilize their student to understand what is the financial problem they are having, what are the logistic problems they are having. So all the problems we can do as a dissertation, we can understand how to solve the problems.
Sir, how much percentage of masonry is allowed, brick aggregate is allowed while making that?
And then see, brick is like brick you are telling, that aggregate they are mixed
How
there.
much percentage of brick masonry?
Our aim is to materials, like when you do as a road contractor, I need only less than 2% of water assumptions capacity. See, if any stages that when we are removing brick from the aggregate, that is cycle aggregate, so when we achieve less than 2%, that is okay. So our criteria, because if we porous, then it will be, will be less. Crushing strength will be high. Your truck will be going to crush the
Because
aggregate.
strength of brick and aggregate is different.
That
Different
is the major challenge actually.
challenge, no? That's why, because you know that water means adsorption capacity means you are having more porous.
Mixing all.
But
Allows our criteria is not percentage of how much. We want to achieve our less than 2% water pipe capacity.
Yet to be studied.
So that by the field which will not get crushed. Because you having 8% means brick is having more porous in nature. So porous means if load will come, it will get crushed. So we don't want. That's why our aim is it should be less than 2%. Water absorption. So that will be okay. You bring anything. That's why like concrete. You told M40. You don't tell that what you think you put inside. You water you put, whatever you put. You told M40 strength I require. Correct. Like court case that Atul Singh must be told. That, like so whatever you put, you petrol, diesel, I need for M40 strength. So that is a criteria. Same way our aim is to 2% less than water surface should be there. You put aggregate should be whether 100% brick it is there, but less than 2% is good. Understand?
Yes. Thank you.
We extend our heartfelt gratitude to Dr. Rakesh Kumar sir for his insightful speech on building smart cities through the effective management of construction and demolition waste. His expertise and innovative perspectives have provided valuable guidance on sustainable practices that align with modern urban development goals. His contribution has not only enlightened us but also inspired actionable strategies for achieving smarter, greener cities. Thank you, Dr. Kumar sir, for sharing your knowledge and vision with us. For felicitation of Dr. Rakesh Kumar sir, I would like to call Professor Krishnaraj Khatri sir. location